In this clip we're going to cover how to measure the orientation of a landform with respect to the geographic north and report our measurement in degrees from north. You're looking at a map that shows an area covered by dunes. Those dunes are sort of tooth or blade shaped. They have steeper contours on one side, more widely spaced, flatter contours on the other, and that steeper side is the downwind direction. In other words, wind that made that dune came from the opposite direction. It was a northwesterly wind that shaped this dune. Gentler contours on the upwind side, steeper, more closely spaced contours on the downwind side. We'd like to know the direction of wind that made this dune in degrees from geographic north. Our first step is to draw a line that divides that dune into equal halves. Again, our dune, blade or chevron shaped, it's asymmetric. Steeper downwind side, gentler on the upwind side. A line that divides that dune into equal halves would look something like this. We're going to want to measure the angle that that line makes with a line that runs straight north-south. Here's a north-south running line. We're going to want to measure the angle this line makes by going clockwise from north using a protractor. Again, we're always going to measure our angles in degrees clockwise starting from north. So north is 0 degrees. We're going to measure clockwise the angle that our line makes with a line running straight north and south. North is 0 degrees, east 90 degrees, south 180 degrees, and west is 270 degrees. In other words, we keep measuring around in a clockwise direction. One full circle is 360 degrees, such that by the time we get almost all the way back to north again, we've gone 359 degrees. We go one more degree, we're at 360, we're back at north again, we're 0 degrees. So directions or angles in the northeast quadrant will be range between 0 and 90 degrees. In the southeast quadrant will be between 90 and 180 degrees. In the southwest quadrant will be between 180 and 270 degrees. And in the northwest quadrant will be between 270 and 360 degrees. Now in this particular example, we know that the wind came from the northwest. In other words, our result is going to be in the northwest quadrant between 270 and 360 degrees. We're going to have to measure nearly all the way around the circle. And the reason we know our result has to be in the northwest quadrant is that the dune is asymmetric, more closely spaced contours, steeper on the downwind side, and more widely spaced contours on the upwind side. In other words, the wind that made this dune came from that direction. In other words, because the contours are steeper on the downwind side, gentler on the upwind side, we know that the wind came from the northwest, producing steep contours on the downwind side, widely spaced contours on the upwind side. To measure this angle, we have two choices. We can go all the way around the circle to get an answer that's between 270 and 360, in other words, in the northwest quadrant. Or we can measure the smaller angle, A, and subtract the result from 360. In other words, 360 minus A gives us the wind direction, the angle that we want, without having to measure nearly all the way around the circle. So that's what we'll do. We'll take our protractor. Let's measure this angle, the smaller one, and subtract that from 360, a full circle, to get the angle that we want. The answer is going to give us the direction the wind came from in degrees from north. Using a protractor, I find that this angle is approximately 40 degrees. 360 minus 40 equals 320 degrees, equals the wind direction measured in degrees from north that made this dune.